Hi, good day to everyone and honorable judges. I would like first of all to thank the organizers of this competition and having us here. Let me start by saying a few words about my background. My name is Ravindran Rajan and I'm an undergraduate student from Faculty of Bioengineering and Technology from University Malaysia Kelantan. Before getting into the presentation, I would like to like my supervisor Dr. V. Thank you and my colleague Mr. Lee Kayang as in the screen. Without them today, it would have been an impossible. Without further ado, I'm here today to present about bioleaching of iron-shaped impurities from different particle sizes and concentrations of ilmenite ores by Shevnella Ordnance MR1. We're happy to present the process of our project to the judges and everyone. In my presentation, I'll be focusing on three main parts. Here we have the world's most important reservoir for the titanium and the ilmenite. The ilmenite is basically a mineral composed of various elements and serves as the most important source to the titanium and titanium dioxide. Due to their composition, they are magnetically weak and high energy is required to leach out the titanium. Like there's always a notorious villain in every movie, in our research, iron was the antagonist. Iron is not found in their elemental form, but they are always bonded in compound forms sharing with other elements, making them available in various valency. In ilmenite, particularly, iron takes the form of iron 3, the ferric iron. They are insoluble in nature and brown in color. This insoluble iron serves an impurity to the ilmenite ore. Iron reducing bacteria, on the other hand, are unique bacteria with the capability of reducing iron under anaerobic conditions. Under anoxic situations, iron reducing bacteria such as Shevnella ordnance MR1, they are best known to reduce iron and manganese through electron transfer. This is helpful to our project because reducing the iron 3 to the iron 2 forms will automatically convert their solubility. Next, I would like to move to our results and discussion segment, which adds value to our project. In this segment, we have 4 different tests and their respective results. To begin with, I'll start off with the Ferrozine assay. The test was conducted during the incubation time to time. Let's look at the figure 1, where the ilmenite grains of 7 different concentrations have been incubated with Shevnella ordnance MR1. Based on a previous study, 0.10 gram per ml of ilmenite concentration showed a maximum iron leaching at 1.4 millimolar. We set up a similar experiment along smaller concentration ranging from 0.10 gram to 0.15 gram per ml. As expected, the leaching was highest in 0.10 gram per ml, which is the black line, and 0.15 gram per ml, which is the blue line, accumulating about 1.457 millimolar and 1.462 millimolar respectively. The results were similar and matched each other, proving that 0.10 gram per ml was optimum concentration for the maximum iron leaching. Moving to the figure 2, here we have manipulated the particle sizes. The largest size was the 350 micron, which is the red line, and the smallest was the 32 micron, which is the dotted yellow line. Looking at the graph, the differences are very much noticeable that the leaching was highest in 32 micron ilmenite, dotted yellow line, or treated with Shevnella ordnance MR1. Iron to accumulation was recorded 0.754 millimolar, which was 7 times of the 351 microns. Therefore, the ilmenite particles of 32 microns, which is a dotted yellow line or smaller, will result a greater reduction for the Shevnella ordnance MR1. Selectively done towards 32 micron ilmenite particles due to the impeccable iron leaching based on the Ferrozine test earlier. As expected, the weight loss difference between the untreated blue bar and the treated with the Shevnella orange bar are almost 2 times. In a nutshell, the Shevnella reduced the iron to its soluble form in the media, thus losing the weight of the ilmenite grains. The results we obtained from the scanning electron microscopy was much more interesting because, as you can see in the images here, there are noticeable changes towards the morphology of ilmenite grains, with and without the Shevnella. I'd like to emphasize that the picture on the right, treated with the Shevnella, identified with several spots that seemed corroded, which was absent in the left picture, which was negatively controlled without the Shevnella. To sum up, we suggest that the Shevnella indeed leached these iron oxides from the grains, causing the corroded spots, as you can see in the screen right now. The final test was the X-ray diffraction method. We compared the dominating crystal phases present in each sample. As you can see in the figure 5 on our left, the red spectra without Shevnella was dominated by iron and iron-based compounds, but the green spectra, which is on top, where the ilmenite treated with the Shevnella displayed more titanium compounds such as rutile. summarize, the iron oxides which suppressed the titanium compounds were leached out remarkably by the presence of Shewanella ordinances MR1. In conclusion, the radioactive dissolution process was highly influenced by both particle size and concentration of ilmenite ore. The optimum concentration and particle size in this experiment was 0.10 gram per ml and 32 microns respectively, that showed incredible dissolution activity. SEM showed the transformed surface of the grain, meanwhile XRD indicated the altered crystallization phase after the ilmenite ore been treated with the Shewanella ordinances MR1. Findings from this research indicate that the Shewanella ordinances MR1 has a great potential to overcome the issues that were stated in the problem statement.